Hello students, welcome back to today's class on playing with numbers, and today we're going to have a small quiz. Right, although we have moved to other topics as per the requirement of few students, as per their request, once again I'm going to solve few problems from playing with numbers. Right, so let's see what is the first question, and my name is Avinash and I'm a graduate from IIT Kharagpur. Okay, so let's see what is the first quiz question here. When 52416 is divided by 312, the quotient is 168. Find the quotient when 52.416 is divided by 0.0168. When 52416 is divided by 312, the quotient is 168. Find the quotient when 52.416 is divided by 0.0168. You should be very careful here. You should be very careful with all the decimal values. 52416, 52.416, and here it is 168, here it is 0.0168. So please quickly do that. Let's see what is the answer. 312 or 3120, 2840, 3260. Right, so I'll give you 1 minute time to solve that. Try to do it fastly. Do it quickly so that we'll try to see. 312, 3120, 2840, 3260. 52416. What is the information we are having? 52416 divided by 312. The quotient is 168. Or you can actually interchange these two places, the quotient, right? So you can write this as 52416 divided by 168 is equal to 312. You can also do in this method. But now the question is 52.416 divided by 0.0168. So using this information, using the decimal values, decimal points, so quickly try to do this question. Quickly do that question. 52.41 in the numerator we shifted decimal by 3 places, whereas in the denominator we shifted by 4 places. So both not the same. We need to take care of that. So how can we eliminate decimals, let's say? So what I'll do, I'll multiply into 1000 by 1000. So why I'm doing this one? So that I can eliminate decimal values and I can write in this format. That will be equal to 52416 by 123. So that will give you 16.8, right? We need 168. We should do with 10,000. Let us do with 10,000. One more zero because we have 4 decimals. So 52416 by 168 So how can we use this information to get the answer? Because we have this result, we'll write this as 52416 into 10 by 168. 52416 into 10 by 168. So that will give you 312. That will give you 312. Is that correct? 52416 by 168 is 312, but not this one. You have one more 0 coming here, so that will give you 3120. That will give you 3120. That is the option B. Right? So quickly understand that and copy that so that we can move for the second question. Very easy. The only thing is you need to be very confident with the decimal values, how to avoid that. Either you multiply or whether you divide, you need to eliminate decimals so that you can try to use this result. Okay, moving forward, the value of 3 into 0.3 into 0.03 into 0.003 into 30 is equal to. So 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243, maybe, I'm not sure. But we need to be very careful with all the decimals again. So please quickly do that. 0.00243, 0.243, 0.0243, 0.000243. So you can do it quickly. 3 into 0.3 into 0.03 into 0.003 into 30. So all the numbers multiplied 1, 2, 3, 4, 5. 3 into 3, 9, into 3, 27, into 3, 81, into 3, 243. The number will be 243. But where is the decimal point? Where is the decimal point? Okay, so point, here 1 decimal, here 2, and here 3. 1 plus 2 plus 3. How many? 6 decimals. we're having 6 decimal places, right? 1, 2, 3, 4, 5, 6, 6 decimals and 1 0, 1 0. So please quickly do that and tell me what is the answer. It's a very easy question. You can do it very easily. You can do it very easily. The only thing is you need to understand where to place the decimal value, because we have decimals as well as 1 0 at the end. Okay, or if you're confused, 243 into, you can write this 30 as 3 into 10, right? So that there you will be having 10 and 6 decimals. So 1, 2, 3, 4, 5, 6. This is equal to 430. Now you need to come back by 6 places. You need to come, the unity place the decimal by 6 values. 1, 2, 3, 4, 5, 6. Okay, so that will give you 2430. 2430, 6 decimal places. 1, 2, 3, 4, 5 and 6. So that will give you 0.00243. 0.00243. That will give you option A as the correct answer. Once again, please cross check that. There may be some calculation mistake somewhere. Okay, so there may be some calculation mistake somewhere, maybe a 00 or single 0 or 000. Once again, try to get rectified, try to get clarity on how the decimals are going to change. Okay, so the next one, the equivalent vulgar fraction or fraction, both are same. Okay, vulgar fraction or fraction, both are same, of 3.004 is, the fraction of 3.004 is, so we have 751 by 250, 75 by 250, 751 by 25 and 751 by 25. So 3.004, we can write this as 3004. We removed 3 decimal places, 1, 2 and 3. So we need to keep that many zeros in the denominator. You need to keep that many zeros in the denominator. Okay, so 3004 by 1000. So now try to get solved and try to get the correct option. Either it is 250 or 25. How to write that? First divide with 4. Okay, so 4 into 250. Okay, let me see. 4 and 3004. For 7's 28, 2, 0. For 5's 20, 0, 4. For 1's are 4. It is 750, right? 751. 751. We have all the 3 options. 751. By 1000 is there. 1000 multiplied, divide with 4. 4 5's are, sorry, 4 2's are 8. And we'll have to 2, 0. For 5's 20. And one more 0 is left. So that will give you 250. One more 0 is left. That will go to 250, right? So that will give you 250 by 751. So that will give you 250 by 751. 250 by 751. So the equivalent vulgar fraction, once again let us sorry, it's not 2, it's a reverse, right? 3004 is 751. 751 by 250. 751 by 250. So that will give you option A as the correct answer. That will give you option A as the correct answer, right? 751 by 250. Moving ahead, the value of 2 centimeters 2 mm is equal to, the value of 2 centimeters and 2 mm. You can carefully see, this is in terms of centimeter and this is in terms of millimeter. Both are not the same. Centimeter and millimeter, both are not the same. You need to convert either centimeter into millimeter or millimeter into centimeter. And the question is in terms of meters, centimeters, so it depends. Okay, so let's try to see that. 2 centimeters is equal to 200 millimeters. Is equal to 200 millimeters, and we have one more 2 millimeters. So that will give you 202 mm. 202 mm. Okay, millimeters. But still, okay, we don't have 202. So what we'll do? 202 into mm to centimeter. 10 centimeter is equal to, sorry, 10 mm is equal to, okay, 10 mm is equal to 1 centimeter, right? So mm will be equal to 1 by 10 centimeters. So mm is 1 by 10 centimeters, right? So that will give you 20.2 centimeter. Do we have this option? No. we still don't have 20.2 centimeter, but still, okay, we need to convert into meters as well. So, 100 centimeter is equal to 1 meter. So, 1 centimeter is equal to 1 by 100 meters. So, 20.2 into centimeter is 1 by 100, right? So, those two decimals will be transformed, will be moved towards left. That will give you 0.202. 0.202 m. So, do we have that? 0.202. Once again, let's try to see that. 2 centimeters. I'm so sorry, we had done a mistake. 2 centimeters, not 200 mm. 2 centimeters, 20 mm. Okay, let me erase once again. Let me start the question again. Okay. 2 centimeter is 20 millimeters. And this is 2 millimeters. So that will give you 22 millimeters. But we don't have that. 22 millimeters. Right. So 22 by 10 centimeters. If you divide with 10, you will get in centimeters. So that will become 2.2 centimeters. Do we have that? We don't have 2.2 centimeter, right? So let's try to divide with the 100, because 100 centimeter is equal to 1 meter. So it is 2.2 by 100 is equal to, you'll get that in terms of meters, and you'll get in that terms of meters. So 2 decimals, 1 and 2, so 0.022 meters. 0.022 meters. So option B is exactly matching to that. Once again, there may be some calculation mistake I'm saying you again, so please try to get rectified, and then you can try to solve the remaining questions, right? Okay, so the next one, express 0.666 in p by q form. We need to write that in terms of p by q, and whenever you have 6 repeating, it will be very easy. Okay, it will not be that tough, right? So what I'll take x is equal to 0.666 and so on. Okay, let's go with 10x. What is 10x? Tell me. 10x equal to 6.666, right? Now tell me what is x equal to 0.666. So subtract this two. 10 minus x is plus 9x is equal to 6.000. So x is equal to 6 by 9. X is equal to 6 by 9, which is a 2 by 3. 6 by 9, which is 2 by 3. That is option C. That is option C, right? Moving ahead, what decimal of an hour will be a second? What decimal of an hour will be a second? So we need to bring some relation between hour and second. Let's try to discuss the basic clock, whatever we will having. 1 hour will have 60 minutes. 1 hour will have 60 minutes. And each minute will have 60 seconds. Each minute will have 60 seconds. So that will give you 3,600 seconds. That will give you 3,600 seconds. Okay. So now, what decimal of an hour will be a second? Okay. So 1 hour is equal to 3,600. So we need what is the value of a second in terms of hours. We need to have what will be a second. That means we need to find the value of second. Okay. So bring this 3600 down. So 1 hour by 3600 is equal to 1 second, right? So what decimal of an hour will be second? So now we need to calculate this one, right? So that will give you 3036 and 1. And we can divide those two zeros later. I am dividing it as 1 by 36 into 100. Okay, so once this is done, so we can talk about that. So 36 and 0.0. No, we cannot. One more 0. Still yes. Now we can go with the 3 times, maybe 36, 3 times, 6 is 18, 3 is 9, 10. No, we cannot go with the 3. We need to go with again 2. Okay, so 0.02. So what is 36 2s? 6 2s are 12, 3 2s are 6, 7. That will give you 72. And the difference will be 28. Once again 0. Right? So carefully check that. 0.02, maybe 7, 36 sevens. 7 is 42, 7 3 is 21, 22, 23, 24, 25. Yes, 36 into 7 will be 252. And then it continues. Right? So now we still have 2 zeros. If you can remember, we forgot 2 zeros there. We left these 2 zeros. Although you got the answer, final answer 0.027. The final value, the final answer will be by 00 by 100 simply. Right. So now you need to convert that again. I mean, bring the decimal again to two places, 1 and 2. 0.00027. 0.00027. That is option C. See, this question looks very difficult, but it's very simple. What is a decimal when we are representing in terms of hour? I can say it is 0.00027. 0.0027 is an hour of a second. Right. Moving ahead. If 0.36 is written in simplest fractions form, then the difference between its numerator and denominator and numerator will be 0.36 is written in simplest form. What is simplest form? 36.36. We can write it as 36 by 100. 0.36 we write it as 36 by 100, right? So now if you divide, 0.36 is written as 36 by 100. So now we need to reduce that. 2 times of 2 18s and to 5 and 0 to 50s. Once again with 2. Once again with 2, right? So 2 9s and 2 25s. So that will give the option 9 by 25. Now what is the difference between its numerator and denominator? So 9 minus 25, that will be equal to minus 16. 9 minus 25 will give you minus 16, right? So when you talk about difference, when you talk about difference, the difference is always a positive quantity. Difference is always a positive quantity, so the difference of these two numbers will be 16. The difference of these two numbers will be 16, right? Next one. 21.114 minus 14.28. How do you take away the decimals? 21.114 minus 14.28. Right? So what is the difference? 4 will come here. We're trying to subtract, right? So 4 will come here. This is a 10, this is 0. 10 minus 8 is 2. Again, this is 0, this is 10, 10 minus 2 is again 8. If I'm not wrong, once again, please check that. Right? So it is 20 minus 14, maybe 6.824. 6.824, maybe 6.834 we are having. Once again, let me check that. There may be some calculation mistake somewhere. Let me check that again. 21.114 minus 14.28. It is 0. 4 minus 0, 4. 11 minus 8 is 3. This is 0. So 10 will come here. This again becomes 0. Right? So 10 minus 2 will be 8. But 20 minus 14 is 6. 6.834. So for now, you can go with the option B, 6.834. 834. It's already 11, right? Right. It's already 11. Okay. 11 minus 2, that becomes 6934. Right. So moving ahead, the difference between the decimal part and integral part in 1.63 into 6.3 is equal to. The difference between the decimal part and integral part, 1.63 into 63. So first of all, let's try to multiply these two. Right? So 3 3s are 9, 6 3s are 18, 3 1s 3 4. 3 3 is 9, 6 is 18, 3 1s 3 4. Right? So that becomes 489. And 6 3s are 18, 6 6 36 37, 6 1 6 7 8 9. That will give you 9, 16, 7 for 12, 13, 9 plus 1 is 10. Right? So that will give you 10369. The difference between the decimal part and integral part. Difference between decimal. Okay, now we need to take care of decimal value, decimal place. So how many decimal values are here? 2 and here 1. So total we have 3 decimal places, right? So come here 1, 2, 3. So we'll get it as 10.369. Right? Okay, so next one. So difference between decimal and integral, that means we need to divide, between the decimal 369 minus 10. Okay, so that will give you 359, but still there is something we left. Once again, let's try to recall that. 1.63 into 6.3, this is 9, 6 is 18, 19, 3 1s 3 4, that's correct. 6 3s are 18, 6 6 36 37, 3 will come here, 6 1 6 7 8 9, 9 16, 7 4 11 12, sorry 7 plus 4 11, 11 plus 1 is 12. So that will give you 10 269. So 10, 269. So now the value will be 10.269, right? So this will also will come exactly 10.269. What is the difference between these two? 269 minus 10. 269 minus 10 will give you 259. 269 minus 10 will give you 259, right? So that is the option 259. The next one, what is the next question we're having? Which of the following numbers is not a factor of 68? 68, I know it is an even number multiplied by 2. 4, I don't think so. Yeah, it is. 4 into 15 or 17, right? 17. 17 and 6. 6, 17. 17 into 4, let's say. 7 4 28, 4 1 4 5 6. 17 4s. And I don't think it will be cancelled with 6. 6 10s or 6 11s will not give you 68. Which of the following is not a factor? So option 6 is not a factor. Alright. So I hope you understood this lecture of all the quiz, all the practice questions. In the coming classes, we're going to discuss more advanced level applications like this, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so today we'll be discussing about pinhole camera. Camera, do we get images using this camera? Yes, we will. Okay, and that's something which you can easily make at our own home. So let's see that, okay. So my name is Seshan Reddy, I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, what you see here in the image is solar eclipse. What you see in the image is solar eclipse, right? And what is solar eclipse here? What happens in solar eclipse? This shining part here, this shining part, okay, that shining part. We might use another color. When you see this, everyone, I'm shading it with red. That one, that area which is shining, that is what? That is actually sun. Sir, but sun should be round. Yes, I agree, sun should be round. But what's happening is here, this part is the moon. There is sun, and in front of sun, moon is coming. So moon is what? Moon is blocking the sun. Moon is blocking the sun, and that is solar. That is what? That is solar eclipse. So again, it happens very frequently. Okay, let me just write it. So there is something which happens twice a year. Okay. And whenever this happens, solar eclipse, generally we also have holidays, okay, in schools. Some of the schools also give holidays on solar eclipse. Why? So that you will not look at the sun during solar eclipse. It's very dangerous. It's dangerous to your eyes. That is the reason. Okay? Okay, that's fine. Then how do we know? How do we get this image? How do we know about solar eclipse then? Is there no way by which we can look at the sun during solar eclipse? Directly we cannot, but we can use this pinhole camera, right? So that's again another important use of pinhole camera. So here, what does this girl think? What does this girl ask? She asks that everyone says I should not look at the solar eclipse directly. So then how can I observe it? Okay, so how can we observe it? We'll go into that. Chalo. So let's first understand what a pinhole camera is, how it is made, or how we can make it in our homes. You can try it at your own home or in your school as a group project. Okay, chalo. So what you will do is the first step, take two boxes. Here you can see in the animation there are two boxes, one a brown and the other a green colored box. So take two boxes. Now you have to take them in such a way that one box is slightly smaller than the other and can slide inside the other. You can see that, right? We can put one box inside the other and we can slide it. So that's one criteria. Then cut open one side of each box. Right? Again, look at the animation. We'll watch it from the beginning. See, we have taken two boxes. We are cutting one side of each box. We have cut them open and then inserting them. Watch it carefully, right? We're again watching it. Two boxes, we cut one side and insert the smaller box in the larger box. Okay, so we have cut one side of each box open. Okay, done. Then the next step will be, make a small pinhole. That's it, very small. I mean, take a safety pin and just make a small hole, a very small hole on the remaining face of the bigger box. Now, which box are we talking about? The bigger box, which is the brown colored box. So look at this animation again. See, at one side it is open. At the other side where it is closed, we make a small hole. Yes or no? I want to draw and show it to you. This is the bigger box. Yes. Okay. This is the bigger box. Right. So here let's say this is the open face where we have cut it. So it is open. You can insert your hand in it. Open. And here let's say this is the closed face. So wherever you have the closed face, make a small hole. We'll call it as pinhole. It is very small, or it is so small that we can call it as a pin hole made by a small pin. Okay. Good. So that's what is shown in the animation also. Clear? Good. Next, what will you do? We need a translucent paper in this case. Translucent object in this case. For a simple example, you can make use of a tracing paper. Have you made use of a tracing paper any time? You would have, right, for drawing. You can clearly see here a tracing paper is given. This is a tracing paper. See? Tracing paper. It is placed on a drawing, so you can use it also. So a translucent tracing paper. So what you'll do is cut out a square on the face of the smaller box. So again, see, look at the animation here. This is the open side. On the other side, you're not making a small pinhole, you're making a square shaped size hole. Okay? A bigger hole. A square shaped hole on the closed end of the smaller box. Then you cover it with what? With a tracing paper. Tracing paper or any translucent paper, translucent object, and this will act as what? A translucent screen. Watch the animation carefully, everyone. Watch the animation carefully. Let it start. 1 minute. I'll tell where it will start. Okay, now it started. The closed face. You are making a square shaped hole, a bigger hole, and then on the square shaped hole we placed a translucent screen. Okay, and then on that we place a translucent screen. Hole, square shaped hole, and then translucent screen. Good? Okay. Chalo. Then after that, it's very simple. You have to slide the smaller box inside the bigger box, and the pinhole camera is ready. And the pinhole camera is ready. That's it. As simple as that. Can you make this at your own home? Can you do it? Yes, you can. Sir, where do we find the box? You can make use of a black chart. Take a black chart, buy a black chart. You can convert that black chart into what? Into a box, and then you can use it. Possible. Try that, okay? Okay, good. Let's continue. So how does a pinhole camera work? How do we get the image? That's the question. How do we get the image? So this is the working of it. The animation shows us the working. It should play again. Just a minute. See? So this is the object. This is the object. Here you have a small pinhole. Yes or no? Small pinhole. And here you have what? You have the image. That's it. So image is formed on the screen. Image is formed where? Image is formed on the screen. And if you look at the image, see here the leaves are up, here the leaves are at the bottom. What does that mean? This means we call this type of images are inverted image. Which image? Inverted image. That is, top becomes bottom, bottom becomes top. So the image that we obtain using a pinhole camera will be what? Will be an inverted image. Will be what? An inverted image. And obviously it will be colorful. The green, you can see that here. The leaves are green. There also in the image also the leaves are green. So it will be a colorful image. It will be what? It will be a colorful image. These are some important properties. And how does it work? It's very simple. If this is the object, you have a small pinhole. Through that pinhole, the rays will pass through. I'll just draw it, wait. Right. Let's say this is a small pinhole. Through the pinhole, the rays will pass through, and wherever they fall on the screen, on whichever screen they follow, they form the image. Whichever screen they follow, they form the image. Just a minute. Okay, and this is the screen. On the screen, image is formed. But the interesting property about it is we get an inverted image. Why inverted? You have to look at the rays for the image. So this is the ray. This ray 1, it's going through the pinhole. Then the ray 1 comes at the top. So here the bottom, the ray coming from the bottom is at the top. So here it gets inverted. And the ray coming from the top, after passing through the pinhole, comes to the bottom. Right, so the image that we get will be inverted. That will be inverted. Inverted and colorful. Understood? Good. So we have some properties here. And here, while we were doing this, while we were learning about the pinhole camera, the working of pinhole camera, we considered that light travels in a straight line, yes or no? Even when we learned about shadows, right? So in both the cases, we considered that light travels in a straight line, and that principle is called as rectilinear propagation of light. So pinhole camera works on the principle of rectilinear propagation of light. So I want to show it to you. Let's say rectilinear propagation of light. Propagation will mean traveling. I'll explain the terms to you, that's it. Propagation will mean traveling of light, right? We use propagation with sound also. Propagation of sound, traveling of sound. Propagation of light, traveling of light. And rectilinear, linear will refer to a line. And recti will refer to what? Straight. So, according to this principle, or this principle states that light travels in a straight line. Pretty obvious. Yes or no? So that is rectilinear propagation of light. And based on that itself, we understand, or we understood the working of what? Working of pinhole camera. So it works on the principle of rectilinear propagation of light. Then you can see the rays from the top of the tree fall at the bottom of the screen. And the rays from the bottom of the tree fall at the top of the screen. Yes or no? From top, bottom. From bottom, top. So that is the reason why, or this is the reason why the image is inverted. Very important point. The image in a pinhole camera is inverted. Very important point. You should be able to draw the image, everyone. You should be able to draw the image of this. The object, the image, and the pinhole camera. You might ask me, sir, when it comes to image, right, draw a tree? No, not a tree, but you can just go with this image also. You can just go with this image also. You can just say that this is pinhole. Pinhole, and this is what? A screen. Better make a box here. Better make a box as it is shown here. Okay? Simple. Chalo. So we could see that the image obtained is colorful. We understood that. Inverted, upside down. And real, what does that mean? Real images. Real images are the images that can be obtained on a screen. So here is the image obtained on a screen. Yes or no? Notice that here we get the image on a screen. That means it will be a real image. That's it. Real images are the images that can be obtained on a screen. So it is a real image. And now comes the another interesting point, that is, image is smaller than the object. Mostly. This is mostly true. Why? It depends on as it depends on the distance. Depends on distance between what? Between pinhole and the screen. That is the reason why I am saying mostly. Mostly the distance will be very small. That is the reason why you'll get a smaller image. But if the distance is large, then you'll get what? A larger image in that case. Okay, so some properties. It is colorful, small, inverted and real. Clear everyone? Properties of image formed by a pinhole camera. Good. Chalo. Now we'll go into simple case again, a very simple pinhole camera, right? So here, that's how small the pinhole will be. Can you see that? And in this video, in this animation, they will show us how to look at the image of the sun using a pinhole camera. Or using a pinhole. Just a pinhole, just a hole, that's it. See here. First of all, never look at the sun directly in the afternoon. Sunrise and sunset, it is okay. But during the noon, do not look at the sun directly. Forget about solar eclipse. Even if it is not solar eclipse, during the noon, do not look at the sun directly. It's harmful to our eyes. Okay? Okay. So what can we do? Instead, we can use a pinhole camera. Just make sure a pinhole as shown can instead be used to look at the image of the sun. How? Look at this. We just took a cardboard sheet. On that there was this hole. We put an aluminum foil and we made a hole. Right? So, and you can see there is that hole. Okay? Small pinhole. Yes. On a cardboard sheet. Then we are placing it up and inside a dark box. If you place it, this sun, we are placing it here. Can you see any image? See here, it's colorful, right? It's white. Obviously, sun during the noon will be white. So you get a round image of the sun. It's again shown, but this time focus on the image of sun. You'll get a round image of the sun. They'll show it 1 minute, it will be shown. There you have it. There you can see it. The round image of the sun. And why is the image of sun a circle? Because sun is a sphere. Because sun is a sphere, like a ball, the image of sun is a circle. That is the reason. Okay? So that's similar to a pinhole. A pinhole camera. Yes. Good. So this link, you can refer to this link for the full video. I just shown you a clip, a small clip, but this is a very interesting video. In fact, you can try this at home also. So please go through the video. Okay. Then we understood how to get the image of the sun or how to view the image of sun. Do not look at sun directly, but instead we can look at the image of sun using what? Using a pinhole. Now the same way we can also look at the image of what? Image of solar eclipse using a pinhole. Okay. So here as we have seen solar eclipse, what happens? Moon comes between earth and sun. So moon is between earth and sun. So the shape of sun will not be a circle. It will be a crescent. Yes or no? So something like this. The sun and moon. Only what part of sun is visible here? Only this part of sun will be visible. Only this. So it's very simple. We have taken a cardboard box. We have made a small pinhole. And on the screen, if you look at the image. This will be the image, only this, because that is what? That is the object. The sun is in this shape, so the image will also be in that shape. What happened to this part then? The part that is not visible, for say this part. What happened to this part? That part is covered by the moon. No light is coming from there, so that's why we will not get an image of the sun. Image of the sun completely, instead we'll get a part. Understood? That's using a pinhole camera to get the image of what? Image of a solar eclipse. Okay, obviously, sir, are there any other way to look at the sun during solar eclipse? There are many. Nowadays, you get special glasses using which you can watch solar eclipse. There are special devices, special cameras to do that. All that you have to buy. But this, you need not have to buy. You just need a cardboard, make a small pinhole, you can watch the image. That's it. So as simple as that. You can try it at home also. Okay? Good. So, I've given you a pretty simple example of the solar eclipse. You can see that here. You'll find it interesting to observe that the image of sun will appear to be a crescent, like a moon. See? Image of sun during solar eclipse will appear to be a crescent. Why is that? We discussed that because that other portion of the sun has been blocked by moon. It's not visible because of moon. Got it? This happens only during solar eclipse. No other time. Okay. Now there are examples of natural pinhole camera also. Now look at the image here. Have you seen anything like this anywhere? Have you seen anything like this anywhere? Yeah. If you look at the ground near a tree, on that ground there will be shadow, but there will be small holes also through which light can enter. Right, so this is what? This is the ground near a tree, and if you look at the images here, or if you look at the light, look at the shape interestingly. They are circles, yes or no? All of them are circular. Now why is that they are only circular? I mean, if you look at the leaves of a tree, the leaves of a tree are not circular. No part of a tree is circular. Then how can we get circular openings here, circular light? That is because what happens is, if there are two leaves, I am just drawing a rough image, everyone, okay? So if there are two leaves, this small gap between the leaves, now here it might appear big, but if you actually look at a tree, there will be a very small gap, very small, like a pinhole. That small gap between the leaves of a tree will act as a pinhole. Pinhole is what? A very small opening through which light can pass through. So between leaves also there will be very small gaps, very small pinholes, and we can call them as natural pinhole. Natural pinhole. So obviously through that what happens? Light passes through. So the openings, the gap between leaves act as pinholes. So the image that we get will be of the sun, because the light passing through that will be of sun, will be coming from sun. Now sun is a sphere, sun is a ball. So the image will be what? Image will be circular. Understood? Good. So let's go into a few questions then. There's one question here. Image formed by a pinhole camera is black and white, upright, up is up, down is down, that's a upright, erect, inverted, or all of the above. What do you think is the answer? Image formed by a pinhole camera is A, B, C and D. Yeah, everyone. And the answer will be, image formed by a pinhole camera is inverted. Not black and white, no. Why? Because it is colorful. Upright, no, it is not. Erect, it is inverted. So A and B are wrong, C is correct, and obviously D will be wrong in that case. Okay, good. Next. Which of the following act as pinhole in the natural pinhole camera? We just discussed about that. What acts as the pinhole? What acts as the gap? Leaves act as pinhole. Gaps between the leaves act as pinhole. Water droplets, or none of the above. And the answer is, what is the opening? The opening is the gaps between the leaves. So B, that acts as the natural pinhole camera. Good? Okay. Then, what is the shape of the image of the sun as observed by the pinhole camera, and why is it so? What do you think is the answer, everyone? Shape of image is what? A circle, or you can say a disc, a circular disc. What is the reason? Reason is because sun is a sphere. Because the sun is a sphere. I can say it's a sphere, or in brackets I can say like a ball. That is the reason. That is the reason. Like a cricket ball, like a football. It's round, completely round. Okay, good. Understood? Very simple. Shape of image is circle, and reason is this. Okay, next. Why doesn't the image of the sun look upside down? Because if I use a pinhole camera, I should get it as inverted. Why doesn't it look upside down? Why? Doesn't matter, because if I only look at these two and these two circles, that's it. And if I ask you which is upside down, which is erect or which is inverted, we cannot tell. Because it is symmetrical shape, it is circle, that's it. Because it's what? It's a circle. And so the reason will be because the sun is a sphere and symmetrical. It's a sphere and symmetrical at the same time, so we cannot observe it. And see, everything is of one color. See, if it had been, let's say, black and white. For example, just imagine the sun is like that, half part is black, half part is white. If it is inverted, what will happen? The upper part will be white and the lower part will be black. If it becomes inverted, ulta. But here, what's happening is, even in terms of color, it is symmetrical, it is uniform. The color is the same from top to bottom, color is same. Then how can you say which is inverted, which is erect? We cannot. So even if the image is inverted, it will not appear so. Understood? Good. Next, how will the letter I be visible? How will the letter I be visible through a pinhole? And we need a small letter, small case I. So how will it be visible using a pinhole? Yeah, everyone, how? Remember the properties of what? Remember the properties of pinhole. So here, I is the object. Then what about image? Image will be inverted. So if I do it upside down, this becomes what? Image. Inverted image. I have to do it upside down. So here the dot is at the top. Here the dot comes to the bottom. Dot comes to the bottom. So this is the inverted image. Okay, good. So that's it, everyone. We have discussed about the pinhole camera. You can actually try making a pinhole camera at your own home or at your school as a project. Okay, so thank you. Thanks a lot.